这个我刚才漏掉了一个字，and the matter， 漏掉两个字啊，就是 Feynman 呢，他有一本书啊，这本书呢，其实他的演讲啊，不是他自己写的啊，他的演讲记录下来被转成文字啊，叫做 The Strange Theory of Light and Matter 啊，那它里面基本上没有用到公式，但是其实口头叙述比直接看公式还难。因为他描述什么叫做相位跟偏正的这些东西的时候，要用很多奇奇怪怪的说法啊。比如说我们讲相位，对不对 ？When we talk about phase, we just use the mathematics and write the equation like this. But Feynman have to make the analogy between clock and this angle. So he say something about how the clock rotate to some angle corresponding to the phase. Anyway, the first way to derive the Snell's law is based on the Fermat's principle. And the second way to derive the Snell's law, we can just use electromagnetic wave. Recall that in chapter 1, we have derived the boundary conditions for connecting the electromagnetic fields on the two sides of the interface. Here we have medium 1 having epsilon is equal to epsilon 1, mu 1, and the second medium have epsilon equal to epsilon 2 and mu equal to mu 2. Then the boundary condition tells us that if there is no surface charge or surface current, then the tangential component of E field must be connected. The tangential component of the H field is also connected. The normal component of the D field and the normal component of the B field, okay, are connected. But usually we can use only these two boundary conditions. Using these two boundary conditions are enough. We do not need to, usually we do not need to implement these two boundary conditions. The reason is very simple, because if we do not have electric charge, we have divergence D equal to 0, divergence B equal to 0, curl E is equal to minus partial T, partial B, and the curl H is equal to partial T, partial D. If rho J are both equal to 0. If we substitute the form E by E0 exponential I omega T minus K dot R, the complex representation of the E field, and the corresponding expression for the H and B and the D field. Then we know that the time derivative can be written as minus I omega times b, and this gives us I omega times d. So if omega is not equal to 0, from this equation, we obtain B proportional to curl E. Okay, and the D is proportional to curl H. However, vector analysis tells us that the divergence of a curl is equal to 0. Okay, so from this we get the result divergence B equal to 0 automatically, and from this we find that divergence D is equal to 0 automatically. This means that when we assume the condition that there are no charge and no current, and assume the form of sinusoid monochromatic wave, we have not yet used the K part. We only use the time factor to be exponential I omega. Okay, so we can consider any superposition of different K, but with the same omega. So if we consider the only one omega wave, which means the monochrome single frequency wave. For single frequency wave, we have this relation B proportional to curl E and D proportional to curl H. So according to this result, we find divergence B and divergence D are equal to 0. So these two equations are redundant in the sense, okay? So since they are redundant, 多余的 so any boundary condition derived from them are also redundant. Okay, so in this situation, we can just use these two equations to express the boundary conditions of the electromagnetic wave. So according to these two equations, the E field and H field must connect their tangential part on the two sides of the interface. However, both of which has this exponential factor. So this means that suppose the direction is x direction. So along the surface, suppose that this direction, say x and y direction, and say this is the z direction. So at this surface, z is equal to 0. So this means that the exponential minus I k medium 1 x times x plus k 1 y must be equal to the exponential minus I k 2 x plus k 2 y. Okay, and since x and y are arbitrary, so this means that k1x is equal to k2x, and k1y is equal to k2y. Okay. Now, result implies that suppose this is the interface.